Alright gang, here we are. So now this is the second on-ramp. This is the image processing on-ramp. And we've got this little video. We get 6% just for looking at this video, watching the video. You go watch the video on your time. I'm not going to make you watch it right now. So watch the video. When you're done, come back. And we'll jump on to the next. So when it comes to what we're dealing with, the workflow relative to images. We're going to import the image, pre-process it, segment it, and then we may have some things we need to do post-process, and then we can classify the image. Okay. So that's how we're going to go through this, step by step. So let's jump on to the next section, and we're in the import section. Now, where are we going to get these images from? Now, if we're dealing with local images, and now this is a little misleading because we're dealing with images that are local to MATLAB. They've provided the images, so they know what they are. The system knows what they are. That's something that's built in. We're not always going to use local images. So just keep that in the back of our minds as we're going through what we're going to go through. Alright, so for task 1, we're going to put it in I. And I equals, well, let me go ahead and get the name of that image. I'm going to wrap it in quotes. Paste the name in there. Not lazy, I'm efficient. That's what programmers are. Okay, and then we'll go ahead and submit it, have it evaluate what we did. And it says I doesn't contain the correct image. Okay. Well, that was the image that it said. I think I did what it said. Well, let's see what it says. Use the ImRead function. Ah, okay. So we need to be explicit about this. We can't just say that image goes in there. We literally have to read it in. We'll go ahead and go that route. It read it in, and look what it sees. It sees values in a 600 by 400 by 3 array. All right. So with this, it's a color image. So we're seeing the 3 different levels of it, and then the 2 dimensions, one layer at a time. All right. So let's go on to the next, and we'll play more as we go along with this. All right. Let's go and show. We'll do ImShow I. And I want to see that image. Display it for me. And it's going to display it here in this workspace. And here's our image. So that's what we saw. This is represented by this 3-dimensional array. Now, we talked about this in the lecture today, and I'm not going to go back over it again conceptually, but this is doing what we talked about step by step, how we break it down, either a 2-dimensional array or a 3-dimensional array. And if it is a colored image, it's going to be 3-dimensional. So now we're going to load that into variable I2. Okay. So we say I2. And do that, and it's going to be image 2. see. It says, well, it wanted me to display it as well. Okay. Second line of code. We put that in. Let's say I2. How you like it now? So there we go. And there we go. It's happy with it now. Okay, we'll go to the next task. And now instead of one after the other, well, can we do them next to each other? How can we maybe lay it out a little different? So I'm going to take this code that they provided us. We'll pop that in there. And I want it montaged. And I'll say instead of A, we'll make them I. That's not I1, it's just I and I2. Let's see. Well, there's the two images side by side. We're not looking at the values being stored in memory. We're just looking at the images. Okay. So we'll pop on to the next task. We could go play with it if we wanted to. We got a video we can watch. So I'll pause this video, watch their video, and I'll see you. Here we go. So we're going to deal with color planes, I should say. So what we just saw was a three-dimensional array. So one dimension for each layer of color. And then when they're all blended together, then we get our image. But depending on what we're going to do with the image, we may want to modify blues, reds, greens, whatever it may be. So with that said, let's go do what they want us to do. So they want us to read into I. Okay. Well, let's, you know what, I'm just going to take the code that we had before. I equals IM read, and we'll just do it for image 3. And then, down below it, IM show I. Oh. There we go, IM show I. So we've read it in, we displayed it. So, what else do they want us to do? Well, how big is that? Okay. So we'll declare a variable sz to represent size equals, and use the size function, and we've used that in the onboard. And, oh, they want it for I. Go ahead, submit it. 600 by 400 by 3. Okay. The 3 is the 3 colors. 600 by 400. That's straightforward. All right, let's move on. And now they want us to extract the red color plane of the RGB image I and store it in R. All right. So I'm going to start out with the R. Equals, And we're going to do the same thing that they've done over here, but going to number 1, and then we're going to come down and say I am show R. I've got an extra equals in there. Okay. So RGB, this one dealt with G, this one's dealing with R for the red. Let's go ahead and run it. So we got rid of the red in that image. All right. Let's go ahead and proceed. And now they want us to get the max, using the max function, find the largest value in the given array. So I'll take their syntax, I'll call it Rmax, and for R, let's see what it is. 255. Okay. So we know the highest value that's in there. Right. Let's do rmin. And this is going to tell us the smallest value. Same concept. Looking through all of them. There we go. 0. All right. And we proceed. Go to the next section. All right. So I can take something that is a color image. I convert it, and then I say, you know what, I want to make it a grayscale. And go play with things like that. So we've got an RGB, and it came in, we stored it in I. They showed it. They want us to convert this RGB I to grayscale. All right, so I'm going to take the syntax they gave us. We're going to call it GS, and we're going to use this same function, but instead of A, we're going to use it for I. So we're going to convert I image to grayscale. And this is going to be called GS for grayscale. And it says display it. Well, we didn't display it. And there we go. We'll display it. Well, I'm not even going to go do the extra. I could have done a montage and showing before and after. And we just did that in, not the last one, but a couple of steps back. Okay. Now, find the size of GS and store the result in SZ. Now, we did that before. So, SZ equals size GS. Say, are they happy with it? They like it. It's straightforward. All right. So now there's so much that we can do with the image. We've taken the image and we've looked at it from the 3 different layers, the RGB. We can get rid of a layer. We can get rid of a lot of color and turn it into grayscale. So there's a lot of stuff that we can do, and we can look at the intensity of the image in some kind of histogram to see how bright is this thing, or whatever it is that we want to see. Let's go through, and they've got us loading the image. We look at the pairs of images. One does look brighter than the other, and we can adjust the contrast for one or another. And they say they want us to display the intensity histogram. Okay, ImHist, and we're going to do it for GS. Go ahead and submit it, and there's our histogram. There's a lot of lightness to it, not a whole lot of dark in it. Jump on to the next task. It says display the intensity histogram for GS2. Significantly different, not as bright. Okay. Now, let's go ahead and do the same thing, and we're going to adjust the contrast for GS2 and save the results to GS2 adjust. So I'm going to use their syntax. And then I'm going to do it with GS2. They want us to display GS2 and GS2 adjust side by side. So that's how we're going to do that. We'll take that montage, and they say we're going to do GS2 and GS2 adjust. So there we go. Here's where we adjusted contrast, and we're going to show the before and after. It's pretty straightforward. Go ahead and run it. It liked what we did, and now we can see the impact of what we did. We adjusted the contrast, and now instead of this, we've got a sharper image with the adjusted. Potentially easier to read. That's the goal. Now, let's do the intensity histogram. For GS adjust. And look here. Look at the difference. So this is what it looked like before. Here's what it looks like now. So it's spread out more. We've got some darks that we didn't have before. So we're getting there. About a quarter of the way through. Pause, watch a video, and I'll see you back. Now, welcome back. I want us to explore some images. We'll go ahead and interact with them. Well, let's run this section. So this loaded them, and we can go through and play with these any way that we wanted to relative to what we just did in that last section. So just go through and play with this however you want to play with it. Okay, got that section done. So we've got import and pre-processing done. So let's say somebody imported an image. I do it a lot for I'm trying to think of the name of the app that I've got, but I've got a gas station app that I upload the image, and now recently they don't even have me upload the image because now they're talking with the provider itself instead of me manually uploading the image. But they would have me upload the image before. I suspect oftentimes it looked like this, and they wanted to be able to find out how much did I spend so they could credit me for using that service. So that's that pre-processing part. Now we're going to segment it out and extract the text from it. All right. So let's go on to the next part. I've got another video. Pause me, watch them. All right, now that you've watched them, we're going to proceed. Now, if we go look, what is it that we're going to pull out? Are we going to pull out the ground and the earth? Or are we pulling out the background, space? Let's go look at what they're wanting us to do. And they don't want us to edit this. We've read in an image, converted it to grayscale. So it's color image, now it's gray. They adjusted the contrast, and now we see the image. Okay. Now they're saying create a binary image, BW, by thresholding. Okay. So I'm going to say BW equals